In this video, we're going to review how static class members work in Java. So if you have a static variable or a static member, the way to think of that is static members are shared amongst all objects of that class. So here I have a class and I have three objects of that class. So each object has some non-static variables, and you'll notice those are the same for all three objects, but then they also have access to this static variable and this static final variable, but whatever changes any of the objects make, those changes affect every other object. So these are shared variables, whereas the non-static variables are non-shared variables. And as a refresher, a final variable is a constant variable, so it can't be changed. This is why it has that reddish color in it. So I've written a class that has some non-static and some static members, both variables and methods. So I have two variables, one called static variable, that's a static variable, one that's called non-static variable, that's a non-static variable. And so for the static variable, again, this will be shared by all objects of type static, whereas each of those objects will get its own copy of non-static variable as well as name. I also have a static final variable, answer, that I initialize to 42. And so from here on out, every object will have a copy of answer and it will be 42. It can't be changed. Now to show you how sometimes static members get used, I've created a counter static variable that'll be shared by all the objects. And then each object gets its own number. It's a non-static variable. So in my constructor, I initialize name and the non-static variable based on the parameters of the constructor. Then I increment the counter and I set my num to whatever that counter value is. Now remember, this gets incremented each time an object is created. So at this point, this tells me how many objects of static type I've created, or of class static, I should say. So I can use this idea to keep track of how many objects of a particular class are instantiated. If I have a static method, I don't have to instantiate an object to call this method, but I only have access to static variables. If I try to say my num, you'll see I get an error because I can't make a static reference to a non-static field, my num. So I have to erase that. Now a non-static method can update the static variable or the non-static variable. Now here, the thing to keep in mind is when I update this static variable on this line, it's going to update that for every object because all of the objects of this type share that field. So here's essentially what that will look like. We have static variable, counter, and final that are static variables. Those are shared by every object of the class. And then each object has three additional attributes that are non-static. Non-static variable, name, and my num. So let's create two objects of the static class. So we'll say static1 is new static, and we'll initialize that with the string Kendra and the number 13. And static2 will initialize with the string Seth and 11. So let's print these out. And you can see it prints Kendra and Seth with their associated values. Notice answer is still 42 for both. And the other thing to notice is that if you remember in our toString method, we print num of counter, num being the non-static member, counter being the static member. So when I print this out, Kendra was the first object we instantiated. So my num is 1, but the counter is always 2 because it gets updated when we create Seth. If I swap the order here, you'll see now Seth was created first, so Seth is 1 of 2. We're still printing them in the same order, which is why they're out of order, but I'm creating static2 first, so it's 1 of 2. Now if I just say new Hugo and run this again, notice we have 1 of 3 and 2 of 3 because we actually instantiated another object here. Even though we didn't do anything with it, you can still see how that affects that number that affects both Kendra and Seth. So now let's call the non-static method and we'll pass in 1. And then let's print static 1. So when we do that, you can see that the non-static variable, we added 1 to it. And that static variable increments because in the non-static method, we do increment the static variable. Now, if I print the second one here, you'll see that the static variable has updated in both objects because, again, it's shared by both. So even though we didn't do anything with Seth, we still have the modifications we made when we called the previous method. And the same holds true if we do the same thing we did here, except we call static2's non-static method. And let's pass in a 2 here, so we'll print them both out. And you can see now we've added 2 to this non-static variable. And for the static variable, we've incremented it. And so now both objects see the result of that incremented value. Now we also talked about there being a static method. And we don't need to instantiate any object to call this. And this adds some value to the static variable. So I can say static. Notice that's the name of the class. And then I have a static method I can call. And I'll call that with the value 10. And let's copy these 2 print statements. So let's see what the objects look like when we're done. And when I print this, you can see it's added 10 to the static variable, which being shared by both Kendra and Seth updates both of their static variable attributes. Okay, so hopefully that's a good review of static variables and you understand how they work in Java. So we'll be using static methods and attributes throughout the semester, so it's a good thing to have a handle on. And keep in mind, whether you make something static or non-static is an important design decision that you have to determine if it's the correct thing, based on do you want this value shared by every object of this type, or do you want each object to have its own individual attribute that it can handle and update as it sees fit without affecting the other objects.